Hello everyone, and welcome to this fall 2021 Qualcomm Upstream update. I'm Björn Andersson. I'm a tech lead at Linaro with focus on Qualcomm and an upstream Linux support, and I'm a maintainer for the Qualcomm platform support in the upstream kernel. The maintainers file in the kernel tree is set up such that almost everything that's Qualcomm specific ends up on Linux ARM MSM. As such, this graph of the traffic on this list is a pretty good representation of the activity in our community. The red line here represents the number of patches, and the blue includes replies to those patches. Looking over the last 12 months, we see an average of 880 patches and a total of 1800 emails per month. Among all those emails, we find 250 individuals who sent their first message to Linux ARM MSM during the past year. During the last 2 years, we have seen much more activity from groups who wants to run the upstream kernel in post-market OS, AOSP, or on their routers. We got the productization of the 7C Chromebooks, and we got the AArch64 laptop project. We seem to have hit the point where we went from developing and upstreaming individual pieces for dev boards to lots of people actually running upstream on their devices. The upstream Qualcomm support started with MSM 7200 in January 2008. It was joined by MSM 8660 in 2011. In 2014, we saw a big increase in the upstream effort by the introduction of MSM 8974, APQ 8064, and IPQ 8064. This was also the year when Qualcomm joined Linaro. Fast forwarding, we see 5 new platforms and 37 new devices added in 2021. The result is that we now have 89 boards across 29 different SoCs that will boot the upcoming 515 kernel. We also have a few more platforms under review on the mailing list, so both of these numbers are expected to increase slightly during the remainder of the year. Here is the list of all the supported platforms, ordered by introduction date in the upstream kernel. The highlighted platforms are those that saw non-trivial device tree updates during the past year, and shows that there is activity pretty much across the board. Naturally, the level of functionality varies across the platforms. A couple of them only have enough support to boot to a UART shell on some dev board. On the other end of the scale, we find the LVC21F-109 platform found in Chromebooks, shipping to customers with a kernel very close to what we have upstream. We also find the STM845 and SC8180X Snapdragon based laptops with enough support to prepare and record this presentation. There's 30 platforms listed here, but MSM 7200 was never converted to device tree and was dropped in 2015. Last time we met, SC7180 still had DisplayPort and some audio integration missing. This has now landed. Other than that, we see primarily productization fixes, including things such as power management improvements and suspend and resume fixes. It's really nice to see this level of completeness upstream. The STM630 and 660 device trees were squashed to reduce duplications between the two very similar platforms. A substantial number of patches has been merged, adding interconnects, display, GPU, USB, camera, remote procs, thermal support, and more. STM636 was recently added. This effort is primarily focused on running mainline on various phones, and there's today 6 phones supported across these platforms. STX55 is another platform worth highlighting. It's a 5G modem platform, has a single ARM core, some useful peripherals, and a modem subsystem. This platform is typically used to provide data connectivity to a host computer over PCIe or USB. Our goal is to be able to run the upstream kernel and provide the same level of data connectivity as downstream. A large part of the platform support is upstream at this point, and we're currently working towards adding MHI endpoint support. Please check out Mani's talk tomorrow for more on this project. 8250 and RB5 continue to gain functionality. A bunch of core platform improvements landed during the year. Display subsystem and HMI bridge was enabled. Audio and PCIe support was introduced. Venus, the video encode-decode hardware, gained 8250 support. Unfortunately, Wi-Fi and Bluetooth is still missing, as these depends on some conclusion in the discussion about how to do power sequencing for PCI devices. Following the SC7180 platform is 7280, for which the upstream support has grown rapidly. The list is long, but things as CPU FREC, cluster idle, storage, interconnect, IPA, core site, USB, thermal, and fuse management have already landed. Most, if not all, of the remaining scope is on the list for review. An area worth special mentioning is data connectivity. The polishing work of the IPA driver continued, particularly related to suspend resume and handling of modem crashes. Recently, the driver received PM runtime support as well. The driver gained support for MSM8998, SC7280, SDX55, and SM8350 this year. Previously, user space was lacking details about the platform-specific IPA configuration, which is needed to configure the modem for data call. A sysfs interface was introduced to expose these details. The ARMNet driver gained QMAP v5 support, including hardware checksum offloading. The driver also saw a bunch of cleanup work that made it more maintainable. During the end of last year, we got the MHI net driver, but the modem control channels were never exposed to user space, so it wasn't possible to establish a data call when using the upstream kernel. The efforts of resolving this led to the introduction of W1 framework, which now supports the MHI modem and the MBIM control channels. This enabled libqmi and libmbim to bring up a data call for PCI attached modems. Recently, an SMD control driver was added to the W1 framework. A network driver for the BAM DMAX was posted during the summer, but has not yet been merged. Together, these would give data connectivity with integrated modems on older platforms, such as 8916. For integrated modems, libqmi were still missing some pieces to configure the connection between IPA and the modem. These were added to libqmi during the summer, and modem manager were taught about the interaction between IPA and ARMNet. The result of these efforts are out-of-the-box data connectivity when using upstream kernel and recent user space for USB, PCIe, and integrated modems. This has been tested on x86 as well as Qualcomm and non-Qualcomm host devices. Some examples are out-of-the-box LTE support on the Lenovo Yoga C630, the OnePlus 6, and the 7C Chromebooks, and 5G support is supported on the Lenovo Flex 5G. Efforts in benchmarking the performance on RB3 showed some unexpected results. It turned out that the limits hardware was configured by the bootloader to throttle the CPUs at 65 centigrades. A driver for the LMH hardware was implemented and integrated with the CPU FREC driver to provide thermal pressure to the scheduler. Following the downstream and configuring the thermal limit to 95 centigrade instead resulted in up to 30% improvement in some benchmark. For example, when running Geekbench on the Lenovo Yoga C630, the score is now higher in Linux than in Windows. A long-standing bug in the TSense driver on 8960 was finally fixed, and related to this effort, support for MDM 9607 and IPQ 8064 was added to the TSense driver. The number of platforms gaining interconnect providers continue to grow. On the mailing list, there's currently discussions about implementation of QoS, and there is a provider for 8996 under review. As part of this, a part of the effort of adding new platforms, some duplicated code was identified, and some of the common Qualcomm platform code could be refactored. The benchmarks that led to work on LMH also highlighted some shortcomings related to DDR bandwidth. An outcome of this was that 8150 got DDR and L3 scaling, and in an ongoing effort, this is being replicated to other platforms as well. Check out Tara's talk after the break for more details on the performance work. On the display side, alpha blending support was added, fixing visual artifacts seen in AOSP. The DPU interrupt code was refactored to better handle variations in platforms. And you should check out Dimitri's talk from earlier today on his work on virtualized planes in the DPU driver. The previous support for using two DSI channels to drive a single panels was reworked to allow driving two independent panels. The DSI PHY code saw some large refactoring as well. As with many other drivers this year, the DisplayPort driver received a large amount of productization fixes. On the GPU side, support for Adreno 660, 680 and 7C Gen 3 was added. The DevFrec integration was reworked to improve frequency selection, and support for receiving IOMU fault information into the Adreno driver for debugging purposes was added. The WSN36XX Wi-Fi driver gained Wacom WLAN support. The patches for enabling device-specific firmware was revived and merged, and the long-standing race between the probing of the control and the related RF driver was resolved. This means that Wi-Fi can now be enabled by default on the DB410C and firmware push to Linux firmware. The Qualcomm crypto driver was put through compliance testing and a bunch of issues was corrected. Support for the AEAD algorithm was added, and patching for adding support for a few additional platforms has been circulated on the list, but are yet to be merged. The 845 support in the CAMSS and CCI drivers landed and were enabled in device tree. On the audio side, multi-button headset control support was added, and support for the new WCD938X audio codec was introduced. Work was done in the ALSA UCM project to better support Qualcomm platforms and devices in distros. In some board configurations, the I2C and SPI buses must be operated using the Gen I DMA controller. The lack of this support was blocking access to touchscreen on a number of phones. A DMA engine driver was introduced and wire up relevant I2C masters to resolve this. Some ongoing things. The patches for CPR on 8998 and 660 has been on the list for way too long, but looks ready to be merged. They are expected to be reusable on 8996, which should allow us to close the long-standing feature gap on the DB820C. The SC8180X comes with EDP and two DisplayPort outputs over USB-C. Patches for enabling embedded DisplayPort and supporting the multiple instances of the DisplayPort driver is being iterated on the list. A Type-C controller driver for the PMIC on 8250 has been worked on during the year, and work to support the DSP-based Type-C controller found in the 8180X and 8350 has started. These are needed to negotiate USB-C DisplayPort alt mode. The Qualcomm Wi-Fi and Bluetooth combo chips require power sequencing before they can be accessed on the respective buses. DB820C had a similar issue, but was hacked around using static configuration, but that's no longer possible on the newer versions of the chip and prevents Wi-Fi from being enabled on 8250 and RB5. Additionally, there is interest in powering up the SDX55 PCIe modem found in some phones. Downstream has a framework known as ESOC to handle this, and we hope to be able to replace that. A number of proposals for solving this has been posted, but the discussion is still ongoing. With the SDX55 support being in good shape, PCIe endpoint support was next on the to-do list and have been iterated on the mailing list and seem to be ready to be merged now. On top of this, a MHI endpoint framework and related drivers are being developed and tested. This will allow us to expose the same MHI services to the host machine as seen when running the downstream kernel. Audio Reach is a new signaling processing framework from Qualcomm. The ASOC driver for this is actively being iterated on the list. Lastly, the Snapdragon laptop support continues to evolve. As I said earlier, patches for EDP and DisplayPort are being iterated on the list. The DisplayPort patches for USB-C alt mode support are working but not yet posted. LTE is working on the Yoga C630 and 5G works on the Flex 5G, but enablement of the latter is pending the PCIe support. Unfortunately, the maintainer has a yoke that needs to be shaved for these patches to be merged. On 8180X, backlight is controlled by the LPG block, which is needed to get user LEDs working on a number of other development boards. So these patches were revived and have been through a number of iterations on the list during the last few months. There are some nice improvements in performance, but more work is needed on the low power support and suspend resume. As I said earlier, I prepared and recorded this presentation on my Lenovo Flex 5G and Yoga C630 running a close to upstream kernel. To join the community and contribute, subscribe to Linux ARM MSM and join us on RSC. The 2 RSC channel moved to OFTC this year. Review patches, try running the upstream kernel on your board or try it out on one of the 89 supported devices. Help us fix bugs that you find or add missing things to device trees. Perhaps you can help us clean up the many device tree validation errors. Write an upstream missing drivers for your devices. And last but not least, if you like working on upstream Linux and Qualcomm hardware, Linaro is currently hiring for positions related to this, so please check out the careers page. Thank you.